Hello. Today's Center for Non-Destructive Evaluation will introduce the process of ultrasonic testing. This is a common NDT method using for detecting the defect in the various material. To perform ultrasonic testing, we need to use following equipment and material. Ultrasonic machine. Straight beam probe or 0 degrees probe, 45-degree probe, 60-degree probe, 70-degree probe, and the cable. And the calibration block, for example, IIW V1 calibration block, DAC block, ultrasonic coupling, and test object. In this presentation, we use expand screen to easy see the indication on the screen of ultrasonic testing machine. Firstly, we must set up the examination parameter, for example, range, velocity, as you see on the screen. Then contact probe to the calibration block. And you can see on the screen some back echo indication on the screen. The first one is indication of first time back echo, and the second time, and the third time, and also fourth time. By using the function of calibration on ultrasonic testing machine, we can input the real surface distance of the first echo is equal to the thickness of calibration block. Do the same way with the fourth echo. The support distance of the fourth echo is equal 4 times of thickness of calibration block. And then we can check the second echo and the third echo to verify the velocity and probe zero. The thickness of calibration probe is 25 mm, and now you can see on the screen the support of the first indication is 25 mm, and the second echo, second indication, the support is 50 mm, and the third is 75 mm. In this step, we will examine the base metal of the weld by using the straight beam probe. The lamination in the blade can be detected by this technique. Contact the probe to the object surface using the couplant. Change again to probe value to see clearly indication on screen. Move gauge to the first indication on the screen. Here we can see the thickness of the object is 14.3 mm. Move probe around the interest area. Observe the screen. If an indication appear front of the back echo indication, that is a lamination indication. In the next step, the calibration of angle probe using V1 calibration block.
Firstly, set up the examination parameter like you see on the screen. Contact the angle probe to the V1 calibration block. Move the probe until the maximum value of indication on the screen. The probe index or sound beam axis can be decided as you can see on the screen. In this step, we will determine the real angle of refraction of the probe using V1 calibration block. Firstly, contact the probe onto the surface of V1 calibration block. Move the probe around the lab diameter hole until achieving the maximum of indication on the screen. The real refraction angle of the probe can be determined as you can see on the screen. In this step, we can determine the sound velocity in the material and also the probe delay. Contact the probe on the surface of V1 calibration block and observe the reflection from the curved surface. Move probe until achieving the maximum amplitude of indication. Use a function of automatic calibration on the UT machine. Insert the real saw part distance to the machine. For the first echo, the real value is 100 mm. Do it the same way with the second indication or second echo. Insert the real value for the saw part distance of the second indication or second echo. The real value is 200 mm. After this step, the velocity of sound in the material will be changed and the probe delay is also changed. And the screen displays the real value of saw part distance. In this step, we can use the Ask Me calibration block with the thickness of 19 mm. After this step, we can establish the DAC curve. Contact probe to the DAC calibration block, forward to the side drill hole. Move the probe for achieving the maximum amplitude of indication from the side drill hole. Using DAC function on the UT machine, record the indication from the side drill hole. Do it the same way with longer subpath distance. Finally, you have DAC curve like you see on the screen. In this step, we will examine the weld. Firstly, we will examine the root location. Contact the probe at the distance of 1 skip from the center line of the weld. Move the probe parallel to the weld axis. The subpath distance of the defect indication is less than 1/2 of vpath. Do the same way on the opposite side. Then we can measure the length of the defect. In this step, we can detect the crack at the weld toe. Contact the probe on the surface of object at the distance of 1 skip from the weld toe. Move the probe parallel the weld axis. The defect indication will appear at the distance of 1 vpath. Do it the same
Do
way
tương tự với phía
with
đối diện
opposite
của mũi hạt.
side. In this step, we can detect the subsurface defects such as slag inclusion, porosity, lack of sidewall fusion. Move probe from half skip from center line to full skip from the well toe. The indication of the defect will appear between the one half of part to full part. You can measure the length of the defect by determining the start of the defect and the stop of the defect. Do it the same way on the opposite side.